Thank you very much, Jeffrey, for that kind introduction. Good morning. I don't know about you, but my brain is already pretty full from 2 days of knowledge bombs being dropped, right? It's been pretty amazing so far. And I think this day it's going to continue. We're going to have even more amazing stuff coming our way. So I'd like to ease us into the day. You don't need to take notes. You can close your laptops. I'm just going to tell you a story. I want to talk about networks. Because our world is wreathed in networks. Alongside the naturally occurring networks, like weather systems and food chains, we've got these artificial networks, like shipping routes, supply chains, urban infrastructures. But the networks that fascinate me the most are information networks. How do you get information from point A to point B? Now, for most of the history of mankind, the speed of our information networks was limited to the speed at which a human could travel, either on foot or on horseback. I grew up in the south coast of Ireland, a town called Cove in the harbour of Cork. And in the harbour, there are these towers. They're called Martello towers. They were built during the Napoleonic era, and are mostly defensive fortifications. But the interesting thing is a lot of these are built sort of from one tower you can see the next tower. And all along the coast of England and Ireland, there are these towers with this kind of line of sight. And that means you can build a fairly crude line of sight network, right? Light a fire on one tower, and it could be seen from the next tower, which could be seen from the next tower, right? It's like the lighting of the beacons in Return of the King. But line of sight networks like this, pretty crude, and the information being transmitted was essentially binary, right? 1 or 0, very, very simple. Now, meanwhile, over in France, there was already a system of towers in place that were a bit more complicated. This is a Chappe optical telegraph tower. You see those vanes at the top, right? Those could be arranged into different configurations, which means that you could encode much more information, pretty much the whole alphabet. And so France was kind of wired up, you could say, with this optical network. One tower could see the next tower. And information could travel really fast. But line of sight does have its problems. I mean, first of all, there's the weather, right? As soon as you have inclement weather, you can't see the next tower. And then there's the terrain, the landscape. If there's lots of mountainous terrain, you're going to have to build a lot more towers to maintain that line of sight. Now, all of that changed when we got the electrical telegraph. And this really did change everything. I think it changed the world. I think our modern world was effectively created in the moment that we linked up via the electrical telegraph, Europe and North America. This was the beginning of globalization. And it's hard to overstate just what an undertaking this was, to lay this cable across the Atlantic. It was astounding. It required the biggest ship in the world at the time, the Great Eastern. It failed 3 times. It was basically like the Apollo program of its day. It was such a big undertaking, complete with conspiracy theorists who didn't believe it happened, right? So they managed to lay this cable from Valentia Island in Ireland all the way across the Atlantic to Heart's Content in Canada, in Newfoundland, where there's a little museum to commemorate the location. And from this moment on, communication could be instantaneous across continents. I mean, that's quite something, that the President of the United States could speak to the Queen of England. It sort of changed everything. And there were techno-utopians at the time who said, well, this changes the whole world in such a way that we would never need to go to war again. Why would we go to war with when we can communicate with them instantly and so sort out our differences, right? That didn't happen. It did change the nature of war. I mean, before the invention of the telegraph, because of the speed of information networks, there were, kind of sad byproducts to that. In the War of 1812, the Battle of New Orleans happened after the Treaty of Ghent had already been signed, right? The war was technically over. But after the telegraph had been invented, there were battles being fought in Crimea, and people were reading about it in the newspapers in London the next day. So it really changed journalism, it changed warfare, it changed culture. There were whole new forms of telegraph romances, these books that be published. And of course, there's new jobs came out of it, right? Entire new roles that people had to fulfill, these telegraph operators. There was one telegraph operator, her name was Nora Willis, and she lived in Somerset. in the south coast of England. And she married a local farmer named Charles Clark. She was working at the post office as a telegraph operator. And together they had a son, Arthur Charles Clark. Now, Arthur Charles Clark, he ended up working on radar during World War II, right, detecting incoming aircraft. And towards the end of the war, 1945, he published a piece for the British Interplanetary Society, an august institution, of which I'm proud to call myself a member, in which he described a theoretical idea that if you put a satellite into orbit high enough, then from the Earth, the vantage point, it would appear to be stationary, right? And these became known as geostationary satellites. Now, I should point out, this was 1945. Sputnik wouldn't be launched until 1957. There were no satellites, and yet he was visionary enough to envision this idea of geostationary satellites, and this is pretty much what we got. And for the latter half of the 20th century, these geostationary satellites revolutionized communication. Right? Whenever you had a live satellite link-up, it was thanks to these satellites. And we like to think that that's how the internet works too. Like, oh yeah, I'm sending my signal to space, and there's satellites sending our websites around. But no. Satellite transmission, when it comes to the internet, is basically a rounding error, because most internet traffic goes over underwater cables. In fact, the routes that these cables follow are pretty much the same routes as the telegraph cables, because those were the most efficient routes back then, and they're still the most efficient routes now. They're different wires now. It's fiber optic cables rather than telegraph cables, but fundamentally, we're kind of layering our network on top of that pre-existing network. Now, when it comes to the internet, you might have heard that the internet was invented to withstand a nuclear attack, right? No, not true. What is true is that Paul Baran, who was working at the RAND Corporation, he was worried about making military communications more resilient, and it was he who hit upon this idea of packet switching, that if you had a message, that you would break it into individual packets of information, and that would be an efficient way to route the information around. Donald Davies in the UK came to the same conclusion at the same time. It was a simultaneous discovery. But anyway, Paul Baran's work caught the eye of Leonard Kleinrock. Now, Leonard Kleinrock was working for DARPA, Defense Advanced Research Project Agency, and they had been commissioned to come up with some kind of communication network. And this was higher level education institutions that would be using this network. And this was the ARPANET. It's kind of a precursor to the internet. And the very first message was sent on the ARPANET on the 29th of October, 1969, 10:30 p.m. And it was a very simple command from one computer in UCLA to another computer in Stanford to log on to that computer. So they sent the command, log on. The message was sent, and the whole system crashed after 2 characters. But they kept working on it, and the network grew over time. And more nodes were added to the network, and then more networks started to get added to the network. And now it became important that these different networks could all speak to each other. What you had was a network of networks, or an internetwork, if you like. But they needed to be speaking the same language. They need to have the same underlying protocol. And that's where these two come in, Bob Kahn and Vint Cerf, creators of TCPIP. Now, back then, they were young and idealistic. And what they were concerned about was not making a network that was resilient to nuclear attack. What they wanted to make sure was that the network was resilient to any kind of top-down control, right? That there was no center to the network, that you didn't need to ask permission to add a node to the network. So the real secret sauce of the internet is the fact that it's a dumb network by design, right? So the network is routing these packets around however it wants, and it doesn't care about the contents of the packets. It doesn't prioritize any packet over any other. And that was the genius of TCP/IP, the Transmission Control Protocol and Internet Protocol, was its simplicity. They used to joke at the time that it should be so simple that you could implement TCP/IP using 2 tin cans and a piece of string. So this really simple underlying protocol. If you think about what a protocol is, right? Think in terms of diplomacy. A protocol is simply an agreement. So everyone's agreeing to use this low-level protocol. And then on top of that, you can build more complex protocols to do more complex things. Protocols for sending and receiving email, Gopher, Telnet, the file transfer protocol. And you can create a protocol. You could do it right now. Invent a new protocol. You don't need to ask anyone for permission. Of course, the trick is getting people to use your protocol, right? Because you want to take advantage of Metcalfe's law. Bob Metcalfe, he worked on the ARPANET and invented Ethernet, and his law is something like, the value of a network is proportional to the square of the number of users, basically saying the more people on your network, the more valuable it is. Like the first person who had a fax machine had a completely useless thing. But as soon as one other person had a fax machine, it was exponentially more useful, right? So this is the situation where you had this low-level protocol, and you could just create a new protocol, but you had to convince people to use your protocol. That was a situation when a new protocol arrives on the scene. It's called a Hypertext Transfer Protocol, HTTP, which is just one part of this three-part stack. HTTP, URLs, and HTML all formed the World Wide Web project. HTTP for the protocol layer, URLs as identifiers, and this really simple format called HTML. Altogether, that's the World Wide Web project, which was the creation of computer scientist Tim Berners-Lee, who was working at CERN at the time. And I'd like to point out that this is, the very first web page on Tim Berners-Lee's computer. And at this point, the web only exists on Tim Berners-Lee's computer, and yet he still called it the World Wide Web. Right? That's confidence. So there's a lot of influences went into the World Wide Web. First, the internet itself and that philosophy of being, just simple enough to get stuff done and not having a center and not needing to ask for permission. And there's also, I think, the influence of where Tim Berners-Lee was working. He was working here at CERN, which is just the most amazing place, the European Centre for Nuclear Research. And under the ground between Switzerland and France, you've got the most complex piece of machinery ever constructed by human beings, where at the Large Hadron Collider, they spin it up, they recreate conditions close to the start of the universe, smashing particles together at incredible speeds, and the amount of data produced is simply astounding. And the amount of cooperation required to get this done was astounding. It's an amazing place. You've got all these people collaborating. You've got scientists and you've got students on summer internships, and somehow stuff manages to get done. But it's the kind of place where there isn't really a hierarchy. So in this place, you can't dictate to people like, well, you've all got to use this computer system, you've all got to use this operating system, you've all got to use this hardware or this software. That won't fly at CERN. People can and will use whatever they want. So this was kind of the task that Tim Berners-Lee was trying to solve, is how do we get all these people cooperating with some kind of system where it doesn't matter what kind of computer you've got, where it doesn't matter what kind of operating system you've got, that everything would be interoperable anyway. And he settled on some kind of hypertext system, because he had some experience with hypertext. He had created a hypertext system in the 80s called Inquire. It was named after this Victorian book of manners called Inquire Within Upon Everything. I always thought it would be a great name for the World Wide Web, right? Inquire within upon everything. So all of these ideas are feeding into his brain. He comes up with this proposal, which he puts before his supervisor, and it's got a very boring title, right? Information Management, a Proposal by Tim Berners-Lee. But his supervisor, Mike Sendall, he must have seen something in this, because he scrolled across the top, vague but exciting. And there was one other influence that would have fed into this. You got the internet itself, this idea of having no center. You've got, the structure of CERN, where you can't dictate a particular platform. You've got the Inquire hypertext system he's already worked on. And then there's the fact that when he was 9 years old, Tim Berners-Lee had read a short story called Dial F for Frankenstein that was written by Arthur Charles Clarke, the same Arthur Charles Clarke who came up with the idea of geostationary satellites. And in this short story, the whole world's telephone networks get wired into one. It's kind of a proto-singularity sci-fi story. And all these influences came together in the World Wide Web, and Tim Berners-Lee creates the World Wide Web. Good job, Tim Berners-Lee. And he realized right from the start, it wasn't enough to create a system, you had to convince people to use it. And taking his cue from the protocols underlying the internet, he knew he had to make the bits of his system, the parts needed to be simple enough that people could get started, and yet still powerful enough that they could do their job. Right? It's like that apocryphal Einstein quote that everything should be made as simple as possible, but no simpler. And if you look at the pieces of the World Wide Web, I think that's true. Like, none of these are the best, right? HTTP is not the best protocol, and URLs, they're messy. They're not necessarily the best identifiers. And HTML, it's certainly very simplistic. It's not the best format, but they're all just good enough that people could get started. If you look at HTML, it was really simple when it started off. There wasn't an official, specification for HTML version 1. Never existed. There was just this document called HTML tags, presumably written by Tim Berners-Lee, that listed out the entirety of HTML back then. And the entirety of HTML was 21 elements. And even those 21 elements, Tim Berners-Lee didn't create most of them. He borrowed them wholesale from an existing format that was being used by the scientists at CERN. They were using a flavor of SGML, Standard Generalized Markup Language. And so this was familiar to them as they read about what HTML was. They go, oh yeah, I see. This is like SGML. I can use this. So that was really smart, right? Use what people already knew. Subtly shift their behavior instead of asking them to change their behavior completely. Now here we are, it's over 20 years later. We've got HTML5, and it's got 100 more elements than that original version of HTML. And yet, it's still HTML. It's still the same format. And that sort of blows my mind. Because if you know anything about computer formats, the idea of a format lasting longer than a few decades, still being the same format, is astounding. If you try to open a word processing document from over 20 years ago on a computer today, you're going to have a bad time. But you can open an HTML document written 20 years ago, and you can run it in a browser today. More astounding, you could open an HTML document written today in a browser that's over 20 years old. That's really amazing. How is this possible that HTML could grow this much and still be HTML? I think it's down to a design decision in HTML, how HTML is handled by browsers. Think about what happens when you give an HTML element to a browser. You've got your opening tag, your closing tag, some content in between. Maybe you'd have some attributes on that opening tag, but this is basically a typical HTML element. And the browser shows the content in between the opening and closing tags, and depending on what those tags are, might do something extra, give it a particular styling or give it some behavior, if it's like an A element or a form element or something like that. But essentially, this is what a browser does when it sees an HTML element: display the content in between the opening and closing tags. You all know this. But what happens when you give a browser an HTML element that doesn't exist, an element it doesn't understand? Still got the opening and closing tags, and you got the content in between. Well, what it does is it shows the content in between. Now, what's interesting here is what the browser does not do. The browser does not throw an error. It doesn't say, I don't understand this element, I'm done. It doesn't stop parsing the HTML file at this point and refuse to parse any further. It just sees the tags it doesn't understand, skips the tags part, and renders the content in between the tags. Well, that's the secret sauce, right? That's how we manage to add elements to HTML over time, secure in the knowledge that we know exactly how older browsers would treat these new elements. They'd ignore the tags part, and they show the content in between the tags without throwing an error. That's the power of HTML and this loose error handling model. In fact, we can take advantage of this error handling model with more complex elements. So the canvas element, very complex, right? You script this dynamic stuff to happen inside the element. And if we know that older browsers will display what's in between the opening and closing tags of elements they don't understand, then we can use that to our advantage and say, okay, put content for the older browsers in between the opening and closing tags. Some kind of fallback, right? A link to a non-canvas version of what you've built. And the more modern browsers know to hide whatever's in between the opening and closing tags and implement the canvas stuff. This isn't an accident. This was a design decision. The canvas element started life as a proprietary invention by Apple. This happens a lot in the standards world, where one browser will just make something up, and the other browsers go, ooh, that's good, we'll have that. And then they standardize it, right? But when Apple invented Canvas, it was a standalone element, right? Like image or meta. It didn't have a closing tag. But during the standardization process, they made sure to add that closing tag so that we could do this, so that we could move forward whilst maintaining backwards compatibility. Same with video, right? Same with audio, these new, more advanced elements. We're taking advantage of HTML's error handling model. Talking about standalone elements, right? The image element is standalone, which seems a bit weird because This is the exact kind of element where we'd want to put fallback content in between an opening and closing tag, and yet we're stuck with this standalone element. Why is that? It's kind of down to the history of the image element. When Tim Berners-Lee had created the web, he also started up a mailing list called www Talk, where pretty much everyone who was on the web was on this mailing list, and pretty much everyone who was on the web was making their own web browser. And so this is where they would discuss, moving HTML forward, maybe moving HTTP forward, what things to add to the language. And they were discussing the possibility of there being images on the web. Because, in the first version of HTML, there are no images. It's just text only. And they're discussing back and forth what they should call this new element that would display images. Should it be called photo? Should it be called picture? Should it be called icon? And they're going back and forth. And then Mark Andreessen, who's working on the Mosaic browser, he said, guys, I've just shipped it. It's landing in my browser. It's the IMG element. It takes an SRC attribute, and it's about to land. And everyone else on the mailing list sort of went, OK. Because what they had was rough consensus and running code, right? The old motto of the IETF. Running code kind of trumped all the theoretical discussions. But it wasn't really all that well thought through. We don't get the closing tag. Then how do we put fallback content in? Well, we're stuck with this alt attribute, right, for the alternative content. It's not ideal, but it works well enough for a while. But there's always this feeling with the image element, especially when we're dealing with bitmap raster images, so basically everything that isn't SVG, that it's kind of butting heads against the fluid nature of text on the web, right? Text will just, wrap lines automatically. It doesn't matter how wide a browser window is. You put text on the web, it's going to, flow automatically. You put an image on the web, it's got intrinsic width and intrinsic height. And then, along comes responsive design. Thanks, Ethan. And we have to figure out, how do we get images working in this fluid web, right? Well, we ended up getting a solution, which was SourceSet. And again, I really like the design thinking that went into SourceSet. So the idea with SourceSet is you can tell the browser, well, here are some other images you might want to use, either the higher density or they're larger in size, whatever it happens to be. But the way it works is that SourceSet updates the value of the source attribute, the SRC attribute. So if you try and use SourceSet without having an SRC in there, it just won't work. That's genius. That means you can't use the new stuff without also maintaining backwards compatibility. You have to include the good old-fashioned source. And of course, browsers, older browsers that don't understand SourceSet, they treat attributes they don't understand the same way they treat tags they don't understand. They ignore it. So they'll just get whatever's in the SRC attribute. Same with all the other responsive image stuff we got, right? Source elements with these sources attributes too. You can go crazy and put all this stuff, but you must keep that SRC attribute in there because that's what's getting updated. That's really, really clever. Takes advantage of HTML's error handling model for older browsers that don't understand this stuff. You have to keep backwards compatibility in mind. So HTML has this very loose error handling model that's contributed, in my opinion, to its success and its growth. And CSS is kind of the same. It's got a really similar error handling model. You stop and think for a minute about all the websites out there that are using CSS, which, let's face it, is all of them at this point, right? And how different those websites look, and the styles, the designs, the multitude of them out there. And then you stop and think that all of that comes down to just one pattern, and it's this. You have a selector, properties, and values. That's it. And that's all the CSS that's ever been written and ever will be written. And it's so small and simple. I find it really, really beautiful. Such a simple pattern. Yeah, we got some special characters, curly braces and colons and semicolons for the machines to understand what's going on here. But this is it. This is CSS. Of course, the trick is knowing the vocabulary of selectors and knowing the vocabulary of properties and vocabulary of values, right? But, someone can grok this in a few minutes. And how do browsers behave when they come across things they don't understand with this model? Well, if you give a browser a selector it doesn't understand, it simply doesn't match the selector, and so everything inside the curly braces is ignored, and the browser goes on to the next piece of CSS. It does not throw an error. It does not stop parsing the CSS file and refuse to parse any further. You give it a property it doesn't understand, ignores it. Give it a value it doesn't understand, ignores it. And so CSS has been able to grow over time, the same way that HTML has. We can add new CSS constantly, and we know exactly how older browsers will behave. They'll just ignore what they don't understand. But if you think about the biggest sort of revolutions in CSS in the past few years, maybe the past 5, 6 years, I'd say they fall into two categories. You've got pre-processors and post-processors, right? Things like less and Sass and stuff like that. Who here is using something like that, Sass, less, right? Right. And then the other sort of development is having some kind of system behind your CSS, and some kind of naming conventions in how you do things. There's object-oriented CSS, BEM, SMAX, all of these different things. There's a lot of them out there. Anybody using BEM or anything like that, when they're naming it? Right, there's quite a few. Here's what I find interesting about both of those developments, is that in neither case did we, developers, authors, designers, did we have to go to the browser makers or go to the standards bodies and say, please implement this? Right? In the case of preprocessors, it's because it sits on your computer and it spits out CSS at the end. In the case of these naming conventions, it's because the ability to do this was always in CSS. We're just talking about how we name our selectors, and specifically class selectors. And the class selector's been in CSS from pretty much day one. So we could have been writing BEM 15 years ago. And that makes me wonder, what else is there that's lying in plain sight, right in front of our eyes, and we haven't seen it yet? It's kind of awaiting discovery. I want to come back to that. So CSS and HTML are very resilient because they are forgiving, because they have this lax error handling model. I think this is an example of what's known as the Robustness Principle, or Postel's law. Be conservative in what you send, be liberal in what you accept. And browsers are very liberal in what they accept. John Postel, he worked on the internet as well, on the ARPANET. He was behind the DNS system. And he was talking about networks when he coined this robustness principle. Right? The idea that if you receive a packet that you're supposed to route further on, and the packet is badly formed, but you still know what to do with it, well, just pass it on, right? Don't be a dick about it. Just pass on the packet. But if you're sending packets, try to make sure you're sending the most well-formed packets you can. Be conservative in what you send. Be liberal in what you accept. And I see this principle all the time. I see it in the worlds of design and user experience. Eric will mention a few examples of this later on. So CSS and HTML very much using the robustness principle. Now, I think that the reason why they can do that is because of the nature of the kind of languages they are. CSS and HTML are both declarative languages. With a declarative language, you're not giving the computer exact instructions. You're not saying, move the pixel over there and paint this to the screen, right? No, you're simply declaring, well, here's the content I've got, or here's the styling I want, and the computer has to figure it out and render it. Now, that's different to an imperative language like JavaScript, client-side JavaScript in the browser. You do give the computer exact instructions on what to do. That gives you a lot more power, a lot more control. But it comes at a cost. And the cost is that an imperative language like JavaScript can't have the same loose error handling that a declarative language like HTML or CSS does. It wouldn't be any fun to try and program in an imperative language if every time you made a mistake or there was an error, the computer just went, don't worry about it. You would never be able to debug anything, right? So there's kind of this trade-off, which is that, and this is a pretty broad sweeping statement I'm making here, but I would say in general, declarative languages tend to be more resilient because they can be more loose in their error handling, whereas imperative languages, while they're more powerful, are inherently a bit more fragile because they can't have that loose error handling model. And this is sort of the trade-off we have, is that when we need the more extra power, it comes at a cost of fragility. What's interesting is if you look at the history of the web, and we've been confronted with problems, we tend to solve them first at that fragile, imperative layer, figure stuff out, hack it away, and then it finds its way down the stack into the more resilient declarative layer. Like when JavaScript first came around, I remember the two big use cases were rollovers, right? In navigation, changing the background image or something, and form validation, making sure that somebody's actually filled in that form field, making sure that actually looks like an email address. Well, these days, I wouldn't use JavaScript for either of those things. I'd use CSS to do the rollovers, right? We got :hover. I'd use HTML to do that validation with the required attribute, or input type equals email. So they started up here, and they kind of find their way down. And that's a trend that's continued over the history of the web. There was a point, though, it was about 10 years ago, we almost got the worst of both worlds. trigger warning, XHTML2. You might remember XHTML1, which was simply HTML, but reformatted with the syntax of XML. And the syntax of XML is that all your elements, your tag names have to be lowercase, your attributes have to be lowercase, and they have to be quoted, right? Because HTML actually doesn't care. Uppercase, lowercase doesn't matter. Quoted, unquoted. Browser doesn't care. So XHTML1, which was the syntax of XML applied to HTML, was kind of nice, because we all were sort of writing nice, clean HTML. But XHTML2 was going to be a very different beast. They were going to deprecate things like the image element, and they were going to apply the error handling of XML. And the error handling of XML is this. If there is a single error in the XML document, do not parse the document. Right? One error, one unencoded ampersand, and the user sees nothing. Well, this was ridiculous, right? Why would we put this on the public web? And we, authors, designers, developers, we quite rightly rejected this. This was far too fragile to use in production. Good, we didn't want that draconian error handling of XML. Yet here we are, 10 years later. And somehow it's perfectly okay to take the most fragile layer of the stack, which has this, strict error handling, and we use that to render text to the screen. What changed? When did we decide that this was okay? I remember a few years ago, there was a day when nobody could download Google Chrome. Nobody in the world could download Google Chrome. I'm sure heads rolled for this. Here's the reason. You see there's a JavaScript error there in the console? That should have nothing to do with being able to hit that download link and download Google Chrome, right? But the way that that download link had been coded was like this. It had taken the fragile imperative part of the stack and pulled it down into the layer that's supposed to be resilient, the declarative layer. And now you've got the worst of both worlds, right? And if there's just one error in the JavaScript file, the browser will throw an error. It will stop parsing the JavaScript file and refuse to parse any further. That's not so good. And this highlights something I think is as important as Postel's law, and that's Murphy's law. Anything that can go wrong will go wrong. He was a real person, Murphy. He was an aerospace engineer, and thanks to this attitude, he never lost anybody on his watch. And we need to keep this in mind, particularly when we're using JavaScript. I'm not saying don't use JavaScript, far from it, but we need to bear in mind that it's powerful yet fragile. Stuart Langridge put together a whole list of all the things that could possibly go wrong when you're using JavaScript on the web, right? It's a hostile development environment. And some of these things are in the browser, and some are on the network, and some are on the server. But, a lot can go wrong. Sure, a lot can go wrong with your HTML and CSS too, but because of the lax error handling, it's going to be less problematic. So I think we need to accept this. We're like putting our fingers in our ears and going, no, everything's fine. My JavaScript's awesome. Nothing will ever go wrong with it. It's fine. Other industries don't behave like that. Well, probably because they're regulated, but still, the car industry, they make sure that they test for extreme conditions. They strap in crash test dummies and smash the cars against the walls at high speed. Could you imagine if the auto industry decided, we've been thinking about this, and we're not going to strap crash test dummies into cars and smash them against the walls at high speed because we've realized that these cars aren't going to be driven by crash test dummies. They're going to be driven by humans. And they're not going to be smashed into the walls at high speeds. These humans will be driving on roads. So we don't need to test these cars. It's like, we want that to be the default situation. We hope for the best, but you still got to prepare for the worst. On the web, we're hoping for the best, and we're not preparing for the worst. My friend Trent Walton, he's a great designer in Austin, he wrote about this. He said, like cars designed to perform in extreme heat or on icy roads, websites should be built to face the reality of the web's inherent variability. The reality of the web's inherent variability. It's just part of what the web is. And that's not a bad thing. That's what's allowed the web to grow. Its inherent variability is what gives it that reach. We should embrace that. All right, this is all sounding a bit doomy and gloomy, right? I'm saying, we're all doomed. You put JavaScript out there, it's going to break, right? Anything that can go wrong will go wrong. My friends, I did not come here to give you problems. I came here to give you solutions. So I want to share with you my 3-step process for building on the web, which I hope you'll take away. Step 1, identify the core functionality of what you're building. Step 2, you make that functionality available using the simplest possible technology. Step 3, you enhance from there. Okay, sounds pretty simple, so maybe we should go through it one at a time. Identifying the core functionality. Now the key here is the core functionality. I'm not saying you need to sit down and think of all the possible things you want users to be able to do with the system you're building. I'm saying, what's the one thing you want to make sure every user can do? Right? Identify that. Let's say you're providing the news online. Well, that right there is your core functionality. I want to be able to provide the news online. Done. We're not even thinking about technology yet, just what's your core functionality. Let's say you're making a social network where people can receive messages from all over the world and they can send messages to their friends all over the world. That's the core functionality, the ability to send and receive messages. There's a whole lot of other functionality we can add too, but that's the core functionality we want to make sure everybody can do. Let's say you've got a photo sharing service. Well, the clue is in the name, photo sharing. The ability to see photographs, the ability to share photographs. That's the core functionality. And let's say you've got a collaborative writing environment where people can write and edit and share. That right there, that's the core functionality. Writing, editing, sharing. Well, that didn't take long, right? Now we've identified the core functionality. The next step is making that functionality available using the simplest technology, not the best technology, the simplest. The reason why you want to use the simplest technology is because the simplest technology is the one that's likely to be most resilient and likely to be most well supported, and so you get the most reach, which is what you want for the core functionality. When it comes to later functionality, you can go crazy, but right now we want to choose the simplest technology for the core functionality. All right, so I'm putting news online. Well, I would say that the simplest technology to do that is HTML. I'd mark up the news in HTML. I mean, technically, the simplest technology would be a plain text file, right? But I'm going to allow myself to raise the bar slightly and say, we can mark it up as HTML. Done. I've got a social network. I want people to be able to see messages, probably in reverse chronological order. Well, HTML can help with that, right? Ordered list, probably. And I want to be able to send messages. Well, that's what forms are for. In this case, a very simple text input will do it. Done. For the photo sharing service, it's a bit more complicated. I would still have a reverse chronological list, but in that list now I'm going to have images, so the image elements needed. And I am going to use a form in order to share a photograph, but it wouldn't be input type equals text this time, it would be input type equals file. As far as I can tell, that's probably the simplest technology you could use to share a photograph on the web. And in the case of a collaborative writing, editing, sharing tool, text area to write in. All right. If you stopped at this point, I would not hold my breath waiting for the IPO. You've built something that works, and it works for everyone, but it's kind of ugly and it's kind of clunky. And that brings us to step 3. You enhance. And this is where you want to be spending your time. This is where you will differentiate yourself from the competition. And frankly, this is where you can go crazy, because you've now built something that works everywhere. You can go wild at step 3, secure in the knowledge that the core functionality is available to everyone. All right, so for a news website, we've got our news marked up in HTML. Let's add some beautiful layout, you know, start using grid maybe, flexbox, floats, whatever it takes. Now, it might seem weird to think of layout as an enhancement, but if you think about responsive design, particularly mobile-first responsive design, we begin with your regular styles, and then inside media queries, you add the styles for larger and larger viewports. You're basically treating layout as an enhancement. Don't get me wrong. When I say something is an enhancement, I don't want you to interpret that as me saying that something is just an enhancement. Pretty much everything is an enhancement. That doesn't belittle it. Like beautiful web typography. It's an enhancement. It's also absolutely wonderful and something I care about deeply. And now we can do that, right, with web fonts. But, you know, that won't be available to every single browser, to every single user, and that's okay, because the core functionality is available to everyone. We're building this social network. I can input my message, I can see messages, but, you know, it's clunky, right? Let's add some Ajax in there, so that when I send that message, we don't get the whole full page refresh. We just update the one bit of the page that's changed. Let's go further. When other people send messages, let's have those messages arrive in my browser without me having to hit refresh. We got WebSockets, we got all sorts of technologies that can do this. Are those technologies supported in every browser? No, but that's okay. The core functionality is available in every browser. For the photo sharing service, let's use everything we've said so far. We got layout, we got web typography with @fontface, we're going to have Ajax, we're going to have WebSockets. But let's do something with that photograph that lands in the browser. Let's use the file API. This is something relatively recent, it's landed in standards. That means we can access that image before it's even been sent to the server. What can we do with that image? We could start applying CSS filters to it, right? Give a nice sweet sepia tone to that image. Not available in every browser yet? That's okay. The core functionality is, this is an enhancement. In the case of our collaborative writing tool, again, all the stuff we said before, Ajax and WebSockets and all this stuff. But let's not rely on the server for that document you've spent hours writing, right? Let's try and store it locally as well, some form of local storage. We have many different databases in the browser now to choose from. And let's make the network itself an enhancement. Let's use something like service workers. This is the technology I'm most excited about right now. I absolutely love it. And one of the reasons I love service workers, if you haven't heard about it, it's a way of basically making it so that your website can respond even offline. Once the user has visited your website once, you can say, okay, well, if there's no connection, show this page or retrieve this information from the cache. Really, really powerful stuff. And what I love about it is the way it's been designed. You know, I talked about how much I love the design decision behind Canvas or responsive images, right? The source set design model. With service workers, it's been designed so you have to use it as an enhancement. You can't make your website rely on service worker because the first time somebody visits your website, there is no service worker. And so that's why I love it. And that, you know, means the question of, but what's the browser support like for service workers is like, it doesn't matter. Even if it were only supported in one browser, it's still worth using it to give an enhanced experience for that one browser. As it happens, it's supported in a whole bunch of browsers and others will come along. Service workers, really, really cool stuff. Like, I think maybe the most exciting thing to happen on the web since Ajax. Definitely worth checking out. Definitely one to use as an enhancement over your core functionality. So, that's the three-step process. And one of the things I like about this three-step process is that it's scale-free. It works at different scales. I've just been talking about the whole service that you're building, right? And applying this three-step process to it. But you could imagine applying this process at the level of a URL. What's the core functionality of this page? How do I make that core functionality available with the simplest possible technology? And then how do I enhance it? I'll go further. We've all been talking about modular design and pattern libraries and components. You could apply this three-step process to each one of those components. What's the core functionality of this component? What's the simplest technology to make that core functionality available? And then how can I enhance it, right? You might have directions on a website. Well, that's the core functionality, is giving the user directions to a physical address. The simplest technology is you write out the physical address as text in HTML. And then you could go crazy and say, okay, we'll add a map, a static map, and then for the browsers that can do it, let's add a slippy map, an interactive map. Let's give that map some animations. Let's add all sorts of fancy effects to that map, right? You can start layering on those enhancements. What this means is that there isn't this dichotomy, this choice that some people often talk about between either you can have something basic but boring that's accessible to everyone, or you can have something rich and immersive, but that's only available to the latest browsers. I'm saying you can have both, that there isn't a battle. You can have both at the same URL, the same code base. You can provide both. Now, I think there's a bit of a myth about this approach, that this means you're going to spend your time in older browsers, right? Because you're considering older browsers, you're considering how things work if the enhancements aren't available. And so people think, oh, I don't want to spend my time in older browsers. But it's the opposite. Because you spend time at step 1 and step 2, what you're actually doing is you're giving yourself carte blanche to go crazy at step 3 and spend all your time in the newer browsers, trying out the latest APIs that have just landed in one browser, right? Secure in the knowledge, you know exactly how it will behave in older browsers. They get that core functionality. But I get pushback. People look at this and they push back on it, and the pushback comes in one of two forms. First is that people say, this is too easy. Or rather, it's too simplistic. It's naive. Say, yeah. This three-step process might work for a fairly simple website, but it couldn't possibly work for the very complicated web app that I'm building. Now, what's interesting about this line of reasoning is that I've heard it before. I heard it when we were trying to switch from tables and font tags, right, over to CSS. And people say, yeah, that's CSS for layout thing. That's fine for your little blog, your little portfolio site, but there's no way it could scale to a big, complex commercial entity like the one I'm working on. And then, you know, Doug Bowman did the Wired.com redesign, and Mike Davison did ESPN.com, and the floodgates opened. We saw what was possible. And then Ethan comes along with responsive design, shows us the way, and people go, oh yes, Ethan, that's fine for your little blog, your little website. But it couldn't possibly scale to the big, complex thing that I'm building. And then the Boston Globe launches, and we see what's possible. And Microsoft update their homepage to be responsive, and the floodgates open. And there's a real opportunity here for the floodgates to open, for you to prove that you can have something accessible, available to everyone, and yet using the latest and greatest technologies. But the other criticism I get is that this is too hard. So people say, wait a minute. You're saying I spend this time figuring out the core functionality, okay, that doesn't take too long, but then making it available using the simplest technology, okay, that's usually sending data to the server and doing the hard stuff on the server and sending stuff back with full page refreshes, right? And then at step 3, when I come to enhance, what, I've got to redo all the same work again? All the stuff I've done on the server, I've got to redo now in the browser in JavaScript? Well, no, not everything. Remember, we're just talking about the core functionality here. I'm not saying you make sure that everything is available to everybody, right? I'm saying that the core functionality is available to everybody, and then go crazy with the enhancements. Matt Marquis, who worked on the Boston Globe launch, he said, you know, there's a whole bunch of features on the Boston Globe that require JavaScript, but reading the news is not one of them, right? So it's not like you have to recreate everything that you've done on the server and the client. But, I mean, these days, things are getting easier with that, too. We've got JavaScript on the server side. There's this idea of universal JavaScript. But I will say it's true that, you know, there is going to be some duplicated effort. And this is not going to be easy at first. If you're not used to working this way, it's going to be hard. But again, that's familiar. When we were trying to switch from tables and font tags to CSS, I remember people saying, yeah, but I know tables and font tags. It's going to take me a long time to learn CSS. And it was true. The first time you tried using CSS, if you were used to tables and font tags, it was hard. Second time, it was still kind of hard, but it was easier. And the third time, it gets easier. And then it just becomes normal. And if you'd been building fixed width websites for years, and then you tried making your first responsive website, that was hard. It was a world of pain, right? And your second responsive website, that was hard too, but not as hard as the first time. By the third time, you're starting to get into it, and then it becomes easier, and then it just becomes normal. Well, it's the same here. Applying this 3-step process will be hard at first because it requires changing the way you think. But then the second time will be easier, the third time, easier again. It's worth doing it because if you spend a little bit of time, steps 1 and 2, identifying the core functionality, making it available to everyone, what you're doing there is, like I said, you're giving yourself permission to go absolutely crazy at step 3. Use anything you want. Start using grids. Start using any of these technologies you've been hearing about. People often talk about technical debt, right, in programming, the fact that somebody in the past made some decision and now we're really paying for it further down the line. Well, what this does, this gives you technical credit. You spend a little time at the start, steps 1 and 2, you have technical credit for your future self. And ultimately what you're doing is you are accepting, right, the inherent variability of the web. You're replacing these assumptions, JavaScript will always be available and work everywhere, whatever it happens to be, you're replacing those assumptions with an acceptance of the chaos of the web, right? Acceptance of the reach of the web. But that's not how most people seem to be building. Like, let's take this website. This is NASA.gov. And if I were to look at this and apply my 3-step process, I think, okay, what's the core functionality? Well, the core functionality is to provide information about what's happening at NASA. What's the technology? Well, text, so HTML. There's images there. Video, right? That's probably my baseline of technologies. And then I would enhance, you know, obviously CSS and then animations and all sorts of good stuff. But actually, if you visit NASA.gov and anything goes wrong with the JavaScript on NASA.gov, you get this really cool Easter egg of what deep space looks like. Absolutely nothing will render to the screen until all the JavaScript is loaded. You might think, yeah, but that's not going to happen to me. It's going to happen to a lot of people. There's 139 requests on this page, totaling 6.7 megabytes. And that's all got to download before anybody sees anything. So good luck if you're on crappy hotel Wi-Fi. And particularly this, 3 megabytes of JavaScript, which must be downloaded, parsed, and run before anything appears on the screen. That saddens me. Now look, I don't like to point fingers and say, oh, you're doing it wrong. That brings me no pleasure at all. But I will point out that this is NASA.gov, right? So your taxpayers' money is funding this, and this doesn't seem efficient to me. And NASA is strapped enough for cash as it is. It doesn't strike me as the best use of it. Now you compare and contrast this government website to what's happening over in the UK. And believe me, I never thought I would find myself praising anything to do with the UK government, but the government digital services are doing fantastic work, and they've enshrined in their design principles this idea that you layer on functionality. If you build pages with the idea that parts other than HTML are optional, you will create a better and stronger web page. So they're not even talking about reach here. They're not even talking about access for everyone. They're talking about good engineering, that it will be better, that it will be stronger, right? It's just good sense. But that's not the way people are building. And I ask myself, why is that? Why is it developers aren't taking this sensible engineering approach, right? Using Murphy's Law. I fear it's because today we really value developer convenience. And don't get me wrong, I really value developer convenience. I do development, and I want that to be as convenient as possible, but not at the expense of user needs, right? That's got to come first. User needs got to trump our developer convenience. I've often said, if I'm confronted with a problem and I have a choice of making it my problem or making it the user's problem, I'll make it my problem every time, because that's my job. That's what I'm getting paid for, right? Developer convenience is important. User needs are more important. This is why it's called work. Yet the web is filled with examples of people making it the user's problem. Every time you see a CAPTCHA, that's somebody deciding that a problem, spam bots, is better being the user's problem than being the developer's problem. Now, I could think, I shouldn't get upset about the fact that most websites out there are fragile, that they're not being built in a resilient way, that they're valuing developer convenience over user needs. I could take comfort from another law, right? Sturgeon's law. Theodore Sturgeon, another science fiction writer, said that 90% of everything is crud. In fact, I could see this as a competitive advantage. If all the other web designers and web developers out there are building web pages that are fragile and bloated and have 3 megabytes of JavaScript just to render text on a page, then I've got a competitive advantage, right? At Clear Left, if we're building the right way, we're building websites that are robust, that'll be good for us, right? I don't think so. I think actually what ends up happening is this tragedy of the commons, because if 90% of websites are built in this fragile, bloated way, then the perception of the web itself by users is that it's fragile and it's bloated. And that's basically what's happening. People trying to use the web on mobile today, coming across these bloated, fragile websites and thinking, the web kind of sucks. And there's this tragedy of the commons. The thing with the developer convenience is that we've always sort of tried to pretend that the web could be tamed. We create these kind of consensual hallucinations about what the web is. Like many years ago, we decided websites were 640 pixels wide. That's how wide the web is. And then a few years later, it was like, no, it's 800 pixels now. People have 800 pixel wide monitors. That's how wide the web is. And then later it was 1024. And then we settled on this magic number of 960, right? We were only kidding ourselves. We never knew. We never could know. And that's okay. And we'd kid ourselves that everyone's on a fast connection. Or we'd kid ourselves that everyone's got JavaScript, the most modern version, and it'll never fail, right? We're filled with these assumptions. And when we're not doing that, we're complaining about what the web can't do. We're comparing it to other media and saying, web's not as good as CD-ROMs. Web's not as good as Flash. Web's not as good as native, right? It's always been there. I remember when designers and developers going, the web will be so much better when we have more than 216 colors. True story. One time we only had 216 colors to play with. The web will be so much better when we're not limited to these system fonts we have to use, right? Got that. The web will be so much better if everyone would just upgrade from Netscape 4. Then everything will be fine. If those IE6 users would just upgrade, everything would be perfect. If those people who are still on Windows XP would only upgrade, Android version 2 users, they're the ones who are holding the web, right? There's always something we're complaining about. Arthur Charles Clarke went on to collaborate with Stanley Kubrick on a film called 2001. A Space Odyssey, probably his most famous work. Here he is, shortly after the release of that film, being interviewed by an Australian journalist with the most impressive sideburns I've ever seen.
Well, with that movie, 2001, you're projecting us into the 21st century. I brought along my son, Jonathan, who in the year 2001 will be the same age as I am now. Maybe he will be better adjusted to this kind of world that you're trying to portray.
The big difference when he grows up, in fact, if we wanted to wait for the year 2001, is that he will have in his own house, not a computer as big as this, but at least a console through which he can talk to his friendly local computer and get all the information he needs for his everyday life, like his bank statements, his theater reservations, all the information you need in the course of living in a complex modern society. This will be in a compact form in his own house. He'll have a television screen like these here and a keyboard, and he'll talk to the computer, get information from it, and he'll take it as much for granted as we take the telephone.
He'll take it for granted. Well, that's certainly true. Not only did we get that vision of the future, we got better than that. We've got supercomputers in our pockets. Even Arthur C. Clarke couldn't envision that, and yet we take it for granted. We complain about what they can't do. Arthur C. Clarke formulated a series of laws as well. Clarke's 3 laws. And the most famous one is his 3rd law, that any sufficiently advanced technology is indistinguishable from magic. And I would add to that and say that any sufficiently advanced technology is indistinguishable from magic at first. And then, over time, we get used to it, and we don't see the magic anymore. My friend Frank, he wrote a story about 6 years ago now. It's called There is a Horse in the Apple Store. And he describes his experience of going to the Apple Store and seeing a tiny pony in the Apple Store. And he describes that, but he also describes the reaction, or complete lack thereof, from all the other people in the Apple Store looking at the Apple products. Like, there's a tiny pony in the Apple Store. Am I the only one seeing this? And he's taken to calling these things that are right in front of our face, that we don't recognize, he calls them tiny ponies. And I kind of think the World Wide Web has become a tiny pony, something we take for granted and we don't realize its true power. And when I look at the building blocks of the World Wide Web, its true power isn't in the HTML, it isn't in the HTTP, that's just a protocol. This is what the web has that those other media don't have, URLs. The ability to share something instantly, instant software distribution. That's amazing, no app store required, right? But then also the ability to persist over time, that you can provide information and a service, you can provide it instantly, but you can also provide it over the long term, that you could care for your URLs over time, for future generations perhaps. This is something Tim Berners-Lee wrote right back at the start of the World Wide Web. URIs, URLs, they're pretty much the same thing, but he said, cool URIs don't change. And because he was thinking about the future, he included a little footnote here that said, historical note. At the end of the 20th century, when this was written, cool was an epithet of approval, particularly amongst the young, indicating trendiness, quality, or appropriateness. So he's thinking about the future. And I think we should think about the future too. We've got this amazing network, right? We've wired up our world. We've got instantaneous transmission. But maybe we can take it further. What about getting the network off this planet? Things get tricky, right? Packet switching isn't going to be enough. But Vint Cerf, who worked on packet switching, is also working on the next set of protocols for the interplanetary internet. Delay-tolerant networking. This is because the speed of light starts to become a factor. So packet switching is basically not going to cut it. So delay-tolerant networking is a way that we could extend our network into space. And something that had an influence on me in the same way that the Arthur C. Clarke short story, Dial-F for Frankenstein, had an influence on Tim Berners-Lee when he was 9 years old, was I read this book by Arthur C. Clarke called Fountains of Paradise. And in this book, he proposes another idea, and that was the idea of the space elevator. Here you've got a cable. It would have to be situated on the equator, have to be made of something very thin but very strong, carbon monofilament probably, and it stretches out past the Clarke orbit, that's what we call geostationary orbit, to a tether on the other end, and that means you can now shuttle stuff up and down this elevator, and the cost of getting cargo into space drops to nothing, and so the cost of getting our species off this planet and having a backup, that drops to nothing too, right? I mean, the dinosaurs died out because they didn't have a space program. Let's not make that mistake as well. And you might look at this and think, this is ridiculous. What a ridiculous concept. It seems impossible. It must seem as impossible to us as the concept of a wire across the Atlantic Ocean must have seemed to the Victorians in the 19th century. But I think we can do it. We can extend the reach of our networks for future generations. We can extend the reach of the collective knowledge of our species. It's a big responsibility, but we need to be good ancestors. Let's leave behind a web that lasts, a web that's resilient. Thank you.